Hello everyone. Today in this session we'll study 16-bit multiplication. In theory classes also we studied about this multiplication instruction, how multiplication is performed between two 8-bit numbers. Now in this example I have two 8-bit numbers 05H and 04H. Alright. So that when I multiply this one in decimal it will be 20, in hexadecimal it will be 1. 4. Anything multiplied with 0 will be 0. So that what we have in higher byte, what we have when we multiply 5 with 4, higher byte is 0 and the lower byte what we have is 14. When I perform multiplication A, B here, the A register will have the lower byte of the multiplication and the B register will have the higher byte of the multiplication result, right? Now we'll see how to perform 16-bit multiplication. When I say 16-bit multiplication, I have two numbers and each number is 16 bits. What I have is 6151. This is one 16-bit number. The other number is 1010. This is the second 16-bit number. Now how do we perform the multiplication of these two 16-bit numbers? We know how we were performing multiplication in decimal numbers, right? The same process we will follow it here. If we see 10 multiplied with 51, what we have is 510. Similarly, 10 multiplied with 61, what we have 610, and these are spaces what we have. And again 10 is multiplied with 51, what we have is 510. Now 10 is multiplied with 61, so that what we have 610. Now all you need to add all these numbers here. What we have is now the result what we get is 61B2 510 after performing the, if you see this one 10, what we have, right? We're not adding any numbers to this one, so that 10. Now this higher byte result what we have 05, which will be stored in the B register, that we add 10. Again that 10 is, so that whatever is the result, to that again 10 is added here, so that what you get is 2 5 here, right? Similarly, we'll take one more example. What we have, the two 16-bit numbers 6230 right? When I perform the multiplication, how do you perform? 2e is multiplied with 30, what we get is 08A0. Now 2e is multiplied with 62, what we get now 119C. Similarly, 43 is multiplied with 30, what we get 0C90. 43 is multiplied with 62, what you get 19A6, right? Now you perform the addition of hexadecimal numbers here, right? Now if you see this, how actually when we write, we know how to perform 8-bit multiplication, because the multiplication instruction what we have, we use A and B register, both are 8 bits, and it is easy for us to perform 8-bit multiplication. But 16-bit multiplication is little tricky. For this one, how do we, the logic is the example what we have shown here, right? What we do is, first is I'll take two 16-bit numbers and I'll multiply this one. The lower byte of the second 16-bit number is multiplied with the lower byte of the first 16-bit number, and I will store this results 08A0 in some registers. After that, next what I do is I'll multiply 2e with 62, right? So that A will be having 9c and B will be having 11. Now we know that this 08 needs to be added with 9c, and wherever the 08 is stored, that register contents are added with 9c, which is the contents of accumulator, and the result again I will store it in accumulator, and again I will store it in one more register, so that whenever I perform 43 into 30, I get this result, and that whatever the intermediate result I have which are stored in some register, that needs to be added with 90, right? This is how we perform 16-bit multiplication. I'll explain step by step how do we perform 16-bit multiplication, right? As I said here, the process is how actually we perform the multiplication, right? The same process what we follow while writing the assembly language program. Origin. We'll write the code for 16-bit multiplication. Move R6, comma. If you see this, these are the numbers what we have. This is the first 16-bit number what we have. 62 is our higher byte and 30 is our lower byte, right? Similarly, I'll read the second 16-bit number. Move R4, comma, hash 43H. Move R5, comma, hash 2EH. This is our second 16-bit number here, right? The first what we have in register R6 and R7 is the first 16-bit number. In R4 and R5 I've stored the second 16-bit number here, right? And you can see in R6 what we have is a higher byte number, R7 is having the lower byte number, and R4 is having the higher byte, and R5 is having the lower byte number here. If you see this one, what we have is 62, 30, 43, 2e. The same example we will take will explain how the way I'm performing on the paper here. The same steps I'll follow it in while writing the 16-bit multiplication also there. Now first is I'll put all these contents into the registers there. The next what we do, now I need to perform the multiplication. First what you need to do, you multiply the lower byte numbers a comma, which is the lower byte number we have it, r5 is having the lower byte number which is 2e h. That I will copy into accumulator. Move b comma, next lower byte what we have is 30 is stored in r7, right? Now I'll perform the multiplication AB, right? Now when I perform multiplication AB, the higher byte will be stored in B register and the lower byte result will be stored in accumulator, right? Now what I do is whatever is the higher byte, that content I'll move into the register R2 now, right? As I said here, this higher byte needs to be added with the next multiplicand result what we get, right? That's the reason I will store this into one register which is R2 register. Next move A R3 comma A. The lower byte content I've stored it in R3 now. Next move A comma R5. What we have it in R5. Now what I need to do, to EH what we have it, so that now what we have, now I multiplied 2e with 30h, so that what is the result we get here after this one, we get 08A0. A0 will be there in accumulator, 08 will be there in the B register. Now what next, what I need to do, I need to perform the multiplication of 2e with 62. That's the reason first I'm moving this content in accumulator, and 62 I'll move it in B register. Move B comma, where we have the higher 62h R6, right? Now I'm multiplying 2e with 62h here. Now multiplication A B. Again the results where we have, now as I said here, now the lower byte will be stored where, now will be stored in accumulator, and higher byte will be stored in B register. Now as I said here, now Now this 08 what we have, that needs to be added with 9C, right? This is a lower byte result what we have after when I perform multiplication AB. Now, A will be having 9C and B will be having 11. This 9C needs to be added with 08. That's the reason what I do is add A, comma, and where is the higher byte content we have stored there? We have stored it in R2 register. Now add the contents with R2, and the addition result, the sum of accumulator plus R2 will be stored in accumulator. Right? Next again I will move this content R2 comma A. Whatever the content I have it in accumulator, I will store it in R2, because again this result needs to be added with when I perform 43 into 63, right? When I perform 43 into 30, right? That whatever the intermediate result, now I'm storing it in R2. That R2 content needs to be again added with 90H. That's the reason I'm storing it in one more register R2 here. Right? Next, what we have, move A comma B. Now I'll perform add C. If there is any carry because of the addition, I'll say hash 00H. Right? Now what I do is move A comma of B. What I do now, right? B is having the higher byte, and if there is any carry because of the addition of this one, right, that carry also needs to be included. That's the reason since I will including 00 now, right? And if there is any carry, that will be added with the contents of accumulator. Move R1 comma A, move A comma hash 00H, add C A comma hash 00H here, right? Now if you see this one, what I'm trying to perform it for this one is, now here if you see, now since what we should have is, if you see the multiplication of this one, what I get is again 16 bits result what we have, right? The 8 bits what we had, that is stored in R2 and R3, right? Next what I do, I will store the other higher byte, I will store it in R2 and R1 here, right? That's the reason I'm including add C A comma 00H here, right? So this is for the higher 8 bits. Move R0 comma A. Move. Next what I do, move A comma R4. R4. Now what I need to do, I performed what, the 2e is multiplied with 30, again the 2e is multiplied with 62. Now what I need to perform, 43 needs to be multiplied with 30 and 43 needs to be multiplied with 62, right? Now what you do now, first I will take that content what we have, R4 what we have, 43. I'll move into the accumulator. Similarly move B comma, now the lower byte of this 16 byte number is stored in R7. The R7 content I will move into B register. Next I perform multiplication A and B. Add A comma R2 register. We know that the intermediate results what we had. The intermediate result, when I say here add A comma R2, right? This result what we had, the 08 plus 9C what we have, that is stored in R2 register. To this intermediate result, now I need to add the contents of accumulator, right? When I perform 43 into 30, right, the accumulator will be having 90 and this higher byte will be stored in B register, right? So that now what I need to do, whatever the intermediate result I had it, that needs to be added with 90H. That's the reason I'm performing add a comma r2. We know that that intermediate result is stored in r2. We have stored it here in r2 register. Now I will add with the contents of the accumulator. Next move a comma b. Next add c. Now here again, since whatever the intermediate results what we have, that needs to be copied where again it has to move to r2 comma a here. Next what I do, move a comma of p, the higher byte what we had, right? That I will do it. Add c comma a comma of r1, a comma of r1. As I said here, what we done here, if there was any addition because of that number, right? If there was any addition, right, when I perform this one, right, there was a carry to this bit and this result was stored in r1 register, right? Now I'm using that the contents of r1, right? Move a comma of b, whatever is a higher byte result that I move into accumulator, and now I'm adding the contents of r1 with a now, right? Next again I'll move the whatever is stored here, the intermediate results of the multiplication again into r1 register. Move a comma hash 00 h here. Add c a comma r naught. Next move r naught comma a. This is r naught comma a. Next what I do, I need to multiply next what we have. Now we have stored it, the higher 8 bit I'm storing it in r0, the next lower 8 bits I'm storing it in r1, the next the lower 8 bit I'm storing it in r2, and the lower 8 bit we have stored it in r3 here, so that we keep on adding the intermediate results in r2, r1 and r0 registers, right? Next what I need to do, 43 needs to be multiplied with 62. Move a comma where the 43 is stored in r4 register. Move b comma r6. Now I'll perform multiplication ab. Now add a comma r1 here. The whatever addition we have, that result is stored in r1 register, right? If you see this one, what we have now, what we have, this content what we have, the 11 plus 06, that content what you have, that is stored in r1 register. That r1 content needs to be added with a6, right? This result, how we got 19a6, we got because of multiplication of 43 with 62, right? Now the what are the intermediate results, we have it in r1 register, that content needs to be added with a6h, right? That's the reason I'm using add a comma r1. We know that in r1 we have stored the intermediate results there, and that content we are adding. Move next what we have, move r1 comma a. Next what I do, move a comma b, right? And because add a comma of r1, there could be a carry because of this one, that's the reason here I will do add c. If you see, that's the reason in intermediate results we're considering all the carries there. Add c a comma r naught. Move r naught comma a. Now we'll perform end here, right? If you see this one, what we had, because of this addition 11 with 06 plus x, if there is any carry, that carry also needs to be considered, and that needs to be added with 1 9, right? If you know that when I perform the multiplication of these two 16-bit numbers, The result what we get is 19C4 34A0 here, right? Is multiplied with 43 to E. So that what we get here, 19C4 34A0, right? Now we have written the program. This is a little tricky to write the program, because you should know, if you see the program how we wrote is the way how we perform the multiplication, right? Here we consider two digits, right? We know how we actually perform the traditional way of multiplication. The same steps I have followed while writing the assembly language program for performing the 16-bit multiplication here, right? Now we'll store this one, right? You tend to do some of the mistakes here, because if you missed out the intermediate results anywhere, at the end what the result will be the wrong. That's the reason, take an example and follow the steps what you follow there, and equivalent instructions you write it in here. I give a lot of spaces here, but anyhow there is no errors on this one. Now we'll debug this code. First instruction what we have is move R6, 62. I'm moving the content 62 into R6 register. Next one, I'm moving the content 30H in R7 register. Move R4, 43H. 43 will be there in the R4 register. Next what we have, R5 is having 2E. Now I need to perform the multiplication of 2E with 30H. That's the reason I'll move the content R5 into A. A is having 2E and B is having 30. Now I'll perform multiplication of 2E with 30. When I perform multiplication, what is the result we get? A is having A0, B is having 08. The higher byte is stored in B register, the lower byte is stored in A0H there, right? Next, I'll move this content into R3 register, R2 register, and A content I will move into R3 register here. Next, what I perform? Move A, R5. Now I need to multiply 2E with 62. That's the reason I'll move the content R5 into A, and the B content I'll move into this, the R6 content into B register. Now I'll multiply 2E with 62 now. So that what we have, the result, what we have is 119C, right? So that what we have, the first multiplication of 2E with 30, what we got is 08A0. Now I multiply 2 with 62. So that what is the results we have? 119C. Now we know that this A0 content what we have, which is the lower byte content, the lower byte content what we had, that is moved into R3 register, higher byte I moved into R2 register. Now this, whatever is the higher byte register in R2, that needs to be added with 9C. Now what we do, I'll do the multiplication. Next, whatever, add A, R2, because the higher byte result of the first multiplication is stored in R2 register. That I will add it with lower byte number which is stored in accumulator. So that what we have, what we get in accumulator after performing the addition, it is A4. Again, this A4 I will store it in R2 register, because this is an intermediate results, and this, whatever the result we have, again we need to add with what now? After multiplication, 43 is multiplied with 30. So that this intermediate results now that is stored in R2 register, that will be added with 90H. Next, what I do? Move A, of B. Now higher byte what we have is 11 now. We see the higher byte what we have is 11 now. Now what I do, 08 is added with 9C. If there is any carry, that carry also needs to be considered while perform, so that carry needs to be added with 11. That's the reason what I'm doing it here. That higher byte I move into accumulator, add C if at all, if there is any carry. Carry A comma of 00H. Now that content I'll move into R1 register. So that what we have it in R1 is having 11. Right? Next what we have, move A comma hash 00H. And if there is any carry, because of this one, if you see this one also, if there is any carry, and if you take an example, if this is something like FF, right, and if there is, because of the addition of these two bytes, if there was any carry, right, again that will go to the next stage, right. That also, to perform that one, what we have is move A comma hash 00 H here. Next add C A comma 0 H, right. So that what we have it now, this content R0 is having the higher order 8 bits. The next higher order is stored in R1. The next higher order is stored in this one, and the next higher order is stored in R3. So that we know that the intermediate results what we have, it is stored in R2, it is stored in R1, and it is also stored in R0 register. Right? Now, just looking at this one, how we add it here, we need to know where those contents are stored, and that register content needs to be added here. So that what we have, move R0 comma of A. I will store it in R0. Next what I do, now this multiplication 2E is multiplied with 62 30H, that is performed. Now I'll perform 43 multiplied with 30. That's the reason move A comma R4, move B comma R7. So that A is having 43H and B is having now what? I'll perform that move instruction. B is having 30. Now I'll multiply 43 with 30H now. So that what is the multiplication results? A is having 90 and B is having 0C. So that what we have, B is having 0C, A is having 90. Now this 90 needs to be added with the intermediate addition of 808 with 9C. Where that is stored? That is stored in where? In R2 register. If we can see that this result is stored in R3 register, right? This is stored in this intermediate. The next 8 bits are stored in R2. The next 8 bits are stored in R1 register, and the next 8 bits are stored in R0 register. So that what we have, move add A comma R2. That intermediate, the addition result, what we have it in R2 register, that needs to be added with what now? 90H. And the result will be stored in accumulator. So that accumulator is having 34. Now 34 I will move into R2 register. Next what I do, move A comma of B, and because of this addition, if there is any carry, right, that needs to be added with the intermediate results what we have it in R1, right. The higher byte content what we have in B register, that is added with R1, plus if there is any carry, that is added, and the result will be stored in accumulator. So that what we have it is 0C, right. The B content I move into accumulator is having 0C. Now I'll perform the addition. After addition, what we have it is 1E. Again I will move into R1 register. Next what I do, move A comma hash 00H. If at all there is any carry, again that needs to be considered, and this needs to be added with the R0 register. Next what we have, move R0 comma A. Next what I do, 43 is multiplied with 62H here. I'll move the content, multiplication AB I'll perform. What is the result we have? A is having A6, B is having 1, 9 here. right? So that what we have, A6 is there in accumulator, 19 is there in B register. Now whatever is addition we have, this addition result 11 plus 0C, and if there are any carry from the previous byte addition here, that will is also stored, and that this result is where intermediate result is stored. It is stored in R1 register. This content needs to be added with A6. Where is A6? This A6 is stored in accumulator. Now what we have it, add A comma for R1. The intermediate result is stored in R1, that needs to be added with accumulator. When I do perform that one, again that result I will store it in R1. Next, the higher byte what we have, that I will move into accumulator. So that accumulator is having 19, and whatever the intermediate results we had, that is in R0. And because of the previous byte addition, if there is any carry, that also needs to be considered, right? So that the addition of all the higher byte 19 with the intermediate result stored in R0 plus carry bit, that will be stored in accumulator. So that what we have, that result is moved into R0 register there, right? So that what we have now. Now R0 is having, if you see this in R0 is having 19, R1 is having 04, R2 is having 34, R3 is having A0. This is the result what is expected here. R0 is having 19, R1 is having C4, R2 is having 34, and A0 is stored in R3 register here. You can perform the multiplication for any 16-bit numbers, right? Here you give the higher byte number, here you give the lower byte number for the first 16 bit. The next 16 bit you give it here. This is higher byte, this is the lower byte, right? If you see the process, what we followed is how we actually perform the multiplication, right? Just follow these steps. There could be a couple of errors, but you need to debug and modify the code and see whether all the intermediate results and carry you are including while performing the addition, so that when I perform the addition at the end, you should get the right results, right? If you're not getting also, you just need to debug and write the code. Remember this example, because with this example only we have written this program, right? This is how you perform 16-bit multiplication.